If you've taken a pre-calculus class, you probably learned about polar coordinates. Instead of graphing by x and y, you use distance from a center point, which we call r, and angle around from horizontal, which we call theta. And while you were learning about these polar coordinates, you probably had to graph different shapes, like limacons and the topic of this video, roses. A rose is a really cool shape that arises from simple equations in polar coordinates. The equation for a rose looks like this. The first time you graph one, it's relatively satisfying to just plot points and connect them. You can really see the shape emerge. But if you want a shortcut, you might try to predict just from the equation how many petals the rose will have. Your teacher probably told you how to do this too, after a few examples. You look at this number, n, and if it's even, the rose has 2 n petals, but if it's odd, it just has n. Now, if you're like me, you were convinced by the examples that this was true, but that doesn't mean you knew why it was true. Why should I be able to make a rose with 4 petals or 5 petals, but not with 6? Why does the number get doubled only sometimes? One answer is the one that shows up when you trace out a rose. The even numbers get doubled because when you trace them out, they line up so that loops never overlap. But when you trace out an odd rose, it sort of goes back on itself. You've graphed the whole rose once theta gets to pi. If you keep going, you end up with the same points, even though they have different coordinates. So really the odd roses do have 2 n petals, they just overlap. Another way to see this is to move continuously between even roses and odd roses. By moving this slider, I can watch the rose generate as n increases. You can see it come together to be overlapping at odd numbers and spread back apart to be evenly spaced at even numbers. So now you know why odd roses only have n petals. Half of them are hiding behind the others.